Exercise 11C, question number 1. Triangle ABC is right angled at A, and AB is equal to 2 multiplied by AC. Prove that BC squared is equal to 5AC squared. Now this is the diagram, and the triangle is a right angle at point A. Therefore, if we apply Pythagoras theorem, BC squared is equal to line AB squared plus AC squared. In the question, AB is equal to 2 multiplied by AC. Therefore, if we put this value in place of AB squared in the Pythagoras equation, BC squared is equal to 2AC squared plus AC squared. Therefore, BC squared is equal to, the square of 2 is 4. The square of AC is still going to be AC squared plus AC squared. So 4 multiplied by AC squared plus AC squared is equal to 5AC squared. Therefore, BC squared is equal to 5AC squared. Exercise 11C, question number 2. Prove that in any rectangle, the sum of the squares on the diagonal is equal to the square on the 4 sides. Now let this be the diagram of the rectangle with diagonal D1 and diagonal D2. And let the sides of the rectangle be A and B. Now, watch closely. You see that the diagonals of the rectangle divides the rectangle into 2 triangles, 2 right angle triangles. So I'm going to apply Pythagoras theorem to calculate for the length of D1 and D2. Therefore, D1, the square of D1 is equal to A squared plus B squared. And the length of D2 is equal to D squared, which is the same thing as A squared plus D squared. Now the sum of D1 and D2 is equal to A squared plus B squared is equal to the sum of the value of D1 and D2, which is equal to A squared plus B squared plus A squared plus B squared. Therefore, the sum of the squares on the diagonal, which is D1 squared plus D1 squared, D2 squared, is equal to A squared plus B squared plus A squared plus B squared. And this value is the same as 2A squared plus B squared. The question says, prove that in any rectangle, the sum of the squares on the diagonal, which is equal to D1 squared plus D2 squared, is equal to the square on the 4 sides of the diagonal. And the square on the 4 sides of the diagonal is equal to 2 multiplied by A squared plus B squared. Therefore, the sum of the squares on the diagonal is equal to the square on the exercise 11C, question number 3. LMN is an equilateral triangle and X is the midpoint of LM. prove that mx squared is equal to 3 over 4 mn squared. Let this be the diagram of the equilateral triangle. This is L, M, and N. X is the midpoint of Ln. Prove that mx squared is equal to 1 over 3 mn squared. Now, because this is an equilateral triangle, the three sides of the equilateral triangles are equal. Therefore, Lm is equal to Mn is also equal to Ln, and let it be equal to x. Therefore, to look for this line, the value of this line mx squared is equal to x squared minus the value of s over 2. Now, if each of the sides is equal to x, then nx, which is this value, or let me put it this way, x squared is equal to nx squared. And this is the same thing as mx squared is equal to x squared minus, since the three sides are equal and each of the three sides is equal to x, therefore nx is equal to x over 2 squared. The value of mx squared is equal to x squared minus x squared all over 4. And this value is the same thing as 3 all over 4 x squared. Therefore, mx squared is equal to 3 over 4 x squared. Now we know that Lm is equal to Mn and it's also equal to Ln, which is equal to x. Therefore, we can replace x with Mn in the equation. Therefore, the value of mx squared is equal to 3 all over 4 Mn squared. Exercise 11C, question number 4. ABCD is a quadrilateral in which the angles at A and C are right angles. Proof that AB squared minus CD squared is equal to BC squared minus AD squared. So let this be the diagram of the quadrilateral, labeled A, B, C, and D. The angles of A and C are 90 degrees. If we draw a diagonal from B to D, the diagonal will cut the rectangle or the quadrilateral into two right angle triangles. So we're going to use Pythagoras theorem to get the hypotenuse of both triangles. Therefore, DB squared is equal to AB squared plus AD squared. And for the second triangle, DB squared is equal to BC squared plus DC squared, or CD squared rather. Now, because the hypotenuse is common, we can equate these two expressions. Therefore, AB squared plus AD squared is equal to BC squared plus CD squared. The question says we should prove that AB squared minus CD squared is equal to BC squared minus AD squared. So to do that, we are going to subtract CD squared from both sides of the equation. We also subtract AD squared from both sides of the equation. Therefore, AB squared plus AD squared minus CD squared is equal to BC squared. CD squared minus CD squared is 0. Therefore, this expression is AB squared plus AD squared minus CD squared is equal to BC squared. And we're going to subtract AD squared from both sides. Therefore, AB squared minus CD squared, because AD squared minus AD squared is 0, is equal to BC squared minus AD squared. Therefore, AB squared minus CD squared is equal to BC squared minus AD squared. Exercise 11C, question number 5. The quadrilateral ABCD is such that its diagonal intersect at right angle. Proof that AB squared plus CD squared is equal to AD squared plus BC squared. So let this be the diagram of the quadrilateral, labeled A, B, C, and D. And let the diagonals intersect at right angles. So the diagonals intersect at right angles. Let the point of intersection be O. Now I'm going to apply Pythagoras theorem to calculate for the sides of this quadrilateral. I'll calculate for the side AB, side BC, side DC, and side AD. Therefore, side AB squared, which is the hypotenuse of this triangle, is equal to AO squared plus BO squared. BC squared, which is the hypotenuse of this triangle, is equal to BO squared. BO squared plus CO squared. DC squared, which is the hypotenuse of this triangle, is equal to DO squared plus CD squared. AD squared, the hypotenuse of this triangle, is equal to AO squared plus DO squared. Now I'm going to group these expressions in such a way that AB squared plus CD squared it will be equal to BC squared plus AD squared. So how am I going to achieve that? I'm going to equate all the expressions. So I'll do it this way. AB squared plus CD squared is equal to the value of AO squared plus BO squared plus DO squared plus CD squared, which is the first and the third expression, is equal to AO squared plus BO squared plus DO squared plus CO squared. BC squared plus AD squared, which is the second and fourth expression. The values are BO squared plus CO squared plus AO squared plus DO squared. Now, if you watch closely, you will see that this expression is equal to this expression. AO squared plus BO squared plus DO squared plus CD squared. BO squared plus CO squared plus AO squared plus DO squared. They contain the same items. So they are equal expressions. So because these expressions are equal, these two expressions are also equal. Therefore, AB squared plus CD squared is equal to BC squared plus AD squared. Exercise 11C, question number 6. prove that the area of the square on the diagonal of any square is equal to twice the area of the square. Area of the square on the diagonal of any square is equal to twice the area of the square. So let this be the diagram of the square, labeled A, B, C, and D. Let's draw a diagonal from B to D. Let the diagonal be D. And let the sides of the square be S. Therefore, applying Pythagoras' theorem to calculate for the value of the diagonal, D squared is equal to AB squared plus AD squared. D squared is equal to AB squared is equal to X squared, because S is the dimension of the side of the square, plus X squared. Therefore, this is the same thing as D squared is equal to 2S squared. We know that the area of a square is equal to the square of the length or the square of the sides of the square. Therefore, this expression is 2 times the area of the square. And the question says we should prove that the area of the square on the diagonal. Since the area of the square is L squared, we can also conclude that the area of the square on the diagonal is equal to D squared. Therefore, D squared is the area of the square on the diagonal, which is equal to 2 times the area of the square. Therefore, area of the square on the diagonal is equal to 2 multiplied by the area of the square, which is equal to D squared is equal to 2X squared. We proved that the area of the square on the diagonal of the square is equal to D squared, which is equal to 2 multiplied by the area of the square. Now, this expression is the same thing as the area of the square, which is equal to the area of the diagonal all over 2, which is equal to 1 all over 2 multiplied by the area of the diagonal, or the square of the diagonal. So the area of a square is equal to 1 all over 2 multiplied by the square of the diagonal. Therefore, the question says find the area of a square with diagonals each 12 cm long. Therefore, the area of the square is equal to 1 all over 2 multiplied by the square of the diagonal, which is equal to 1 all over 2 multiplied by 144. 144 divided by 2 is 72. Therefore, the area of the square is equal to 72 squared centimeters. CC, find the length of a diagonal of a square whose area is 128 centimeters squared. So let the area of the square be A, which is equal to 1 all over 2 multiplied by the square of the diagonal. So in the question, we're asked to look for the length of the diagonal. So the length of the diagonal, D squared, is equal to 2 multiplied by the area of the square. The length of the diagonal, D, is equal to the square root of 2 multiplied by the area of the square, which is equal to the square root of 2 multiplied by 128. Therefore, this expression is d is equal to the square root of 256. And the square root of 256 is equal to 16 squared centimeters. Exercise 11C, question number 7. Prove that in any rhombus, the sum of the square on the diagonal is equal to 4 times the square on a side. So let this be the rhombus. Let this be the rhombus. The sides of a rhombus are equal. So let this be the diagonal D1 and the diagonal D2. And let the sides of the square be S. So we are going to consider one side of the square. Sorry, we are going to consider one side of the rhombus. So we are going to bring out this right angle triangle with side X. Now, the length of this diagonal is D2. Therefore, half of the length is D2 all over 2. The length of this diagonal is D1. Therefore, half of it is D1 over 2. So we are going to apply Pythagoras theorem to calculate for the side of the rhombus. Therefore, x squared is equal to D1 over 2 squared plus D2 over 2 squared. And this expression is the same thing as D1 squared plus D2 squared all over 4. So now we're going to multiply both sides with the value of 4. If we multiply both sides with the value of 4, 4 will cancel out 4 here. Therefore, we now have 4 multiplied by x squared is equal to D1 squared plus D2 squared. Proof that in any rhombus, the sum of the square on the diagonal is equal to 4 times the square on a side. Therefore, the sum of the square on the diagonal, D1 squared plus D2 squared, is equal to 4 times the square of the sides of the rhombus. Therefore, the sum of the square on the diagonal which is equal to D1 squared plus D2 squared is equal to 4 times, or let's use, is equal to 4 times the square on a side. Which is equal to 4x squared.